You may know hydrological modeling plays an important role in better understanding of magnitude and impact of water issue, and it also takes place at different spatial scales, ranging from individual field stream to global modeling. But the linkage between the global and local scale hydrological modeling is still a challenge in water resources study. So my objective is to propose a methodology to downscale runoff from a global model to basin scale model based on a physical concept combined with a mapping technique. Okay. Firstly, this study was applied for 5 major river basins in South Korea only, including Han, Nakdong, Gyeom, Samchin, and Yongsan. Total area almost 99,000 kilometers square, and this is divided into 109 subbasins with elevation of rate about 715 meters. We can see here. And I also provide some information about temperature and rainfall of this study area, and we can see in the table. So data used for this study, including the observation data, such as meteorological data, as precipitation and temperature, and stream flow data used for calibration. And topography and soil and land use data. And for apply to global model, I realize data at 0.5 degree late long resolution for the period of 1966 to 2006. Firstly, I compare the global and local forcing data. As you can see here, I saw the correlation between precipitation for a daily and annual scale for 3 stations in South Korea, including Sokcho, Seoul, and Jeonju. It's not much high correlation. But this is considered high for South Korea. I also did my comparison for the other basin for other country, and this correlation is quite low for the other country. For hydrologic simulation, I use 2 kinds of model: basin scan hydrological model, squad model, and global hydrological model, click model. And I provide the workflow of these 2 models, and we can see in the slide. Basically, it is use the same same
Miss,
kind of, yeah.
can you use the new tab media setting and share the file PPT file to talk to everyone? Is we can share the presentation file.
Uh,
You can
actually,
drop
can
and drop.
sorry. This one. Oh, not more screen sharing. This is not work now.
Yeah, so you
So sorry, actually, this work not work for now. So maybe it's almost my turn is almost done. So we continue the as previously, and maybe for the second one, second people, the
Okay.
second person can do it like this. Okay. Okay. Basically, the workflow between the basic scan hydrological model and global hydrological model is almost same. And it's also use water balance equation with the same component. But the concept of the model is different. As squad model uses a hydrological response unit concept, and global hydrological model uses a grid cell fraction concept. So this slide shows the calibration and validation result for basic scale model. This is so that the model is satisfactory to use to simulate the variation of stream flow characteristic in the South Korea. But the problem is that this contains different and uncertainty is forcing data, as we can show in the previous slide. And the difference in the concept of the model, as I told before. So, and also the skin separation and skin related breakdown of the concept and assumption between when we down skin or when we link from the global model to basic scale model, or from basic scale model to global model. It contains 4 big problems. It is a simple cell fraction. The conflict between the compartment of the hydrological system, the assumption about the dependent physics, and the consistent chain of scan of subgrid concept and parameterization. Okay, so the question is that can complicated problems be solved using a simple approach? So I propose my method to scan on the product from global model to basic scale using a simple concept that combines the concept of a physical process with a statistical mapping technique for data scaling runoff. And that physical process is the CM value that is widely applied in simulation of runoff in basic scale model, such as SQUAD or other models. So I also provide some results, some initial results. In this table, I present. I saw three kind of results. Apply three different methods. It is area graded interpolation, decision mapping method using the a topographic index, and my method it can call process-based downscaling. Based on four statistical criteria, you can see the process-based method show very promising results compared to the other two methods. It is the next slide present the spatial distribution of the runoff average for 30 years from 1975 to 1976 to 2005. You can see the original output of the big model and the downscaling to the basic scan using the area graded method, area graded interpolation. The decision mapping using the Dune index and the process-based downscaling. So the process-based downscaling so very close result to the original output of squad model. And the next slide, I present the run of country for the subbasin. The first subbasin of the the Han River Basin. But this is basin here the area graded interpolation, so closer result to the original squad model. So okay, there are some conclusion can be done from this initial result. So as the proper method, so-called area process-based downscaling method, so significant improvement in run-up downscaling compared to other methods. Then the CN value estimate using soil moisture-based approach, so slightly closer result than the other CN estimation approach. And the advanced area interpolation method do not act value when target catchment is large enough to be covered by several subzones. But this method should be applied for the other watersheds to avoid region-driven results. And for future consideration, so I'm gonna expand my study area to 10 other river basins, as you can see here. Yeah.
Please see the chat. Please reply.
Thank you for your attention. Thank
Thank you.
Okay.
Okay. Thank you, Ms. Ha. Next presentation is my turn, and I will share my presentation via screen.
To have a list of
Okay.
List of frozen data. If you get that.
Okay.
Okay. Good morning, everyone. Today I would like present my presentation with title water level prediction by using LSTM and extreme gradient boosting in urban basin. And this study we are just at beginning step uh, of this. That's why I only share my idea, my proposal for this presentation. And my presentation includes five sections. The first one is a statement of problem. The second is study area and data collection. And the third is the methodology I use in this study. And the fourth is the expected results and discussion. And finally, I have some conclusion on my on this research. The first problem I will talk about the statement of a problem.
See the chat.
As we know that the urban flood management is a crucial and challenging task, um, mm, particularly in the developed cities. And uh, as we can see in the previous event in Seoul City, I share some picture from historical flood in Seoul 2011. We can see the damage and the inundation in this city, and so that accurate prediction of the urban flooding under heavy precipitation is critical important to address and reduce urban flood risk. Um, Recent years, machine learning techniques have demonstrated advance in terms of timely prediction and assessment in hydrology. Uh, and I make some literature review here. There are a number of previous studies regarding utilization of machine learning models for predicting stream flow and water level, such as gradient boosting in some research. For example, Fan et al. 2018, K 2017, Chen and Gotrin 2016, and long short-term memory. This model also received a mass attention in recent years. However, there is a still gap in previous study in to apply in missing urban area for heavy rainfall events. In addition, the comparison, the performance of the most powerful algorithm, including LSTM and extreme gradient boosting, still need more investigation for the problem. And in this study, I also using the satellite data from the
Your thumb.
integrated multi-state line retrieval for GPM at a future model input. Here I think maybe it is significant to more study on to apply the satellite data in my study. And then my objective for this study is to investigate the performance of the advanced machine learning methods for forecasting hourly water level in the heavy rainfall events. This examination will conduct in Chungrang urban basin that covered by mountainous area in upstream. In the upstream has low urbanized area, and in the downstream area it has the highly urban area. Next section I will talk about study area and data collection. We are at here uh, now we are at here now we are at the step, and the first one I will introduce Chungrang Basin. This basin have the area of 233 square kilometer, and upstream with low urbanization area, downstream with very high urbanization areas. And in this study, we will collect the hourly data from 2005 until now. And in this area, we have 3 water level stations and 8 ground rainfall station will be used. And also we will collect the image satellite data with 0.1 degree spatial resolution and 30 minutes temporal resolution from the NASA website. And I will talk briefly the some algorithm I will be used in this study. The first one is the long short-term memory network, is LSTM. This model is a type of recurrent neural network with a hidden layer replaced by the specially designed memory block that is composed of an input gate, an output gate, a memory cell, and a forget gate. In detail, the input gate determines that with new information generated by the memory cell will be sorted in the cell state, and the forget gate determines which information to remove from cell state. We can see in the figure the above figure show the detailed the long short-term memory, and below is show the unrolled through the time of LSTM network. This network have the getting structure of the neutron. That's why it may be helpful for the time series prediction. It also demonstrated by so many research recently. The second algorithm I will introduce here is the extreme gradient boosting. This is also a powerful algorithm used in recent time, and XGBoost use an ensemble of classification and regression tree cards as the mapping to fit the training data samples. Each card has an independent binary tree decision rule structure and contains a continuous score on each lead node. For given input, the output is sum of the corresponding lead score. As we can see, I saw an example of XGBoost at the figure, and here we can take the input X be a young male at the age of 16 and use a computer daily. Then the mapping result according to ensemble model so equal 2.9, and we can see in the figure XGBoost determine the card through minimizing the flowing regular objective, and here I will show the equation. Now I will talk about my expected result and discussion. Um, Here, the first one, my approach to implement my proposed methods. Um, I will use the input for training hourly rainfall as AWS station, water level as upstream station, and satellite rainfall. And the outputs for training is the 1 hour, 2 hour, 3 hour, 4 hour, and 5 and 6 hours step ahead water level as downstream station. And I will next step I will preparing the different sets of combination input for sensitive assessment of input in this basin. So that expected result here, and I will develop the different step ahead model with based on the algorithm, and um, I will make the um, 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, and 6 hour step ahead water level prediction regarding each set of the combination inputs. And here I will discuss on the set of combination input for model configuration, and we can find the most effect set in the in the basin. This I will find the effect of where uh, um, which input will be the most effective in the basin by using the AI techniques. And then from the models, I can assessment peak water level prediction between the models to get uh, mm, some conclusion. Now I will talk about some conclusion from my study. The first one, conclusion on the hourly step ahead models. It means that the compare between week one is the best model, mm, uh, week model will be helpful for water level prediction. Conclusion on the performance of the algorithm based on comparison of their results, and conclusion on the input effects on the water level prediction in the urban basin, and finally conclusion regarding the peak water level prediction. I am very sorry that the study just at the beginning step. That's why I cannot show you about the initial result or something else. Now I thank you for your attention. Do you have any question to ask me and her? Because I also present the first one, and now I think we have uh, full member here.
Hello, could you hear me?
Okay, we can hear you here, doctor
Okay,
here.
so sorry because I'm late, but the study is quite interesting with me. So because I'm also study about the INN or LSTM.
Mm-hmm.
So um, because you only show you do not show the result. So uh, and I have some recommend or suggestion for you when you apply the model. Uh, Maybe the correlation of the input data will very important. It
Mm-hmm.
means because you are use the LSTM, and the LSTM or INN is a model, is a patch model for the time series data, and it means the correlation of the input data is very important.
Yeah.
Sometimes when we add the rainfall data in the model, it can make noise for the result.
Mm.
So, and another thing is quite important, I think. So, when STM or INAN is the best model for predict for country data, but only for the short time. So, in this case, we predict for one time step, two time step ahead. The accuracy may be up to 99%. But when if you predict for 6 hours ahead, mean the 6 time step ahead, maybe accuracy is degree is maybe only about 80%.
Mm.
So that's
Thank you,
what I
Dr.
think.
Yen. Okay, I will take the attention for the problem when I make the data processing for the input. Also, make some analysis in more detail for that.
Yes.
Okay. Next presentation is from the Mr. Hamid Mohebzadeh and Mr. Tasamli from the Kyosan National University. Please, Mr. Hamid. Sorry, Mr. Hamid Mohebzadeh or Mr. Tasamli. Do you hear now? If they are not here, I think we can move for the next presentation from the Mr. Ngọc Tiến Dương from the Sejong University. Please, Mr. Tiến can show to us his presentation.
Do you hear me?
Okay, now I can hear you. Okay.
Yeah. I don't know how to save my document.
You can select the tab screen sharing
Yeah.
and choose which screen you want to share. Yeah.
Okay.
Oh,
Okay.
sorry. Okay.
I couldn't see your presentation.
You could. Oh. Please with me. Yeah.
Okay.
Do you see?
Yeah.
Okay. Um, Hello everyone. Today I want to present my topic about using EDUA modern to estimate the discharge to discharge in some heavy rainy for Gulf River Basin. Uh, this structure is my presentation include six part introduction, overview of SUR modern, study area and data, rainfall runoff simulation, um, determine loss and conclusion. The first, I want to show the introduction, continuous simulation. Continuous simulation of steam plot for desired blocks estimation in increasing in the different type of runoff generation measured test different modern approach in different region. ADR modern is a semi-distributed continuous rainfall runoff model that improves the estimation of hydrological component. In this study, I using the SUR model to calculate the rainfall runoff and determine the peak discharge for Gulf River Basin. Uh, the SUR model is developed based on storage function model with the better estimation on the hydrological component. The technical program is SUR model use the improvement function code. Uh, in SUR model, using the calculator hydrological component into the soil motion, surface blocks, altitude blocks, and groundwater blocks. About the basin and channel routing estimation, the theoretical method of SUR model is to couple the even model storage function and the continuous hierarchic component. About the study area, I calculate the area for Gulf River Basin about area into the 9,000 over 9,000 square kilometer and based on the Guamis partnership division and hydrological station data, Gulf River Basin is divided into 25 sub-basin and 17 channel, includes 14 hydrological station and 2 dams. About data of hydrological and meteorological data. Look about rainfall using the T-SEN algorithm to determine mean area precipitation for each sub-basin. In the data, in my data, I collect the data from to 79 rainfall observation. Sorry. about the weather data, I collect the hourly meteorological data of temperature, related humidity, wind speed, and solar radiation from 22 stations. And about the hydrologic data, I collect hourly discharge data from 14 stations and hourly loss data up to them. About data, soil data, in SUAMA model, the soil characteristic plays an important role in the evapotranspiration and implementation process of the precipitation on the catchment. About the rainfall runoff simulation in parameter estimates, this table I show the subjective parameter in Rhone River. In area models, there are two types of incorporated parameters, which are the constituent groups, so-called subjective parameter, and physics groups, so-called the objective parameter. The physics parameter can be measured and estimated beyond the basin characteristic when in best data collect if possible. About the calibration and verification process in this data, the simulation period was selected from the 2006 to 2011 to calibrate model and determine a parameter, and then simulation from 2012 to 2017 to validate this parameter set. This table in the screen, I collect data from the 9 station in 9 station for 10 east water catchment and 7 station for 17 channel. And then this is the result compared the simulation, and observation data from the 2006 and from 2006 to 2011 for his cluster, and then for main team. For detail, here an example compare the simulation data of observation data in the even 10 to 11 for his quarter, and for mainstream the same with the process, the same with calibrate process. I want to show the result of, in verification process. This is the compare the calculate the data from 2012 and 2017 for his water, and then for mainstream, and next I want to show the detail of compare the for data compare that stimulation result with observation data for even 2016, and then for mainstream with even 2016. In the first in the next part, I want to show the determined plot using SUR model for determine characteristic rainfall and plot in the Zoom River. Here the result of using SUR model for Zoom River basin. This is a table the maximum hourly rainfall for each catchment. The maximum hourly rainfall reached 60 millimeters per hour. About the basin routing, the basin routing plot is over 8,000 cubic meter per second. About the table, about the channel routing, this is calculate the in the table list the even reach the peaks channel routing. About the conclusion, SUR model simulated rainfall runoff for Gulf River area will use relative consistent result with the real measurement. The maximum hourly rainfall reached the 60 millimeter per hour, and by the routing plot is over 8,000 cubic meter per second. Thank you for the attention.
Thank you, Mr. Tien, for your presentation. Do we have any question for him? If not, we can move to the next presentation from Dr. Hiên with
I
the
have one
title.
more question.
Yeah. Okay.
So, your study is quite interesting. So, I have it's not small. So I need the help from the Dr. Tien because I also have another study about the Kum River. So can I ask you to share about the? I need the small, how to say, is a basin, the map of the Kum basin. Could you send me the email or something like that in the future?
Yeah, thank you, the Dr. Yes, I will send it. Thank you.
Thank you.
Yeah.
Now, please, Mr. Hiên will share his presentation with us.
Believe with me. Why don't you how to share the screen?
Yeah. You do right. You choose the screen sharing. The tab in the left above left, and then you can choose which the screen you want to share.
This okay?
Yeah. Now you can choose the presentation. Yeah.
Oh, you can see.
Yeah. We can see the presentation.
Uh, okay, I will start now. Uh, Good morning, everybody. So, uh, my name is Lê Xuân Hiền, and I come from Yongbuk National University. So, I know about this conference from the last week. So that means there is some error in the book because in the book there is only name from Professor Itiha Vihali and don't have my name. So anyway, today I will present about my research, one of my research, bias correction of satellite-based precipitation using deep learning models. And my my presentation includes five parts: introduction, data and methodology, model design, research discussion, and the last is conclusion. And because I will talk about the application of deep learning in hydrology field, so this slide I will give you some of the basic concept about the deep learning. Uh, uh, Deep learning algorithm is divided into three categories: supervised learning, you can see here, unsupervised learning, and reinforcement learning. Most of hydrology problems will belong to the supervised learning. In supervised learning, there are some neural network, for example, deep forward neural network or ANN, convolutional neural network, recurrent neural network, for example, LSTM, GRE, and the last is encoder-decoder architecture. And in my study, I will propose the deep learning model is a combination of the convolutional neural network and encoder-decoder architecture for correcting the bias of satellite precipitation data. And uh, the have a question is why we need to use the bias correction for satellite-based precipitation data. And currently there are some rainfall data. There are some kind of rainfall data, for example, the ground-based rainfall gauge and the satellite-based precipitation product. However, for the ground-based rainfall gauge, they are poor data and present a limited area around the location of the device. And for the satellite product, for example, GRNN or PCANN, it is difficult to represent values in complex terrain area. That's the reason we need to reanalysis of satellite-based precipitation data by region. However, the best correction method depend on the density of the rainfall station and uh, the bias distribution can be seen clearly in the mountainous area or especially in the developing country. For the last river basin, for example, spanning many countries, collecting the data over the long period is a challenging task, and adjusting rainfall by existing method will face the difficulty due to the spatial distribution of the rainfall station. And in this study, I will propose models based on the deep learning for correcting the bias of satellite product. And the Mekong River Basin has been selected for this study, and satellite-based precipitation data is uh, is Percy and CDR. And the next part is data and methodology. This study, Mekong River Basin, is selected for this study because it is one of the biggest river basin in the world, and the Mekong River Basin spans 6 countries: China, Myanmar, Laos, Thailand, Cambodia, and Vietnam. And for most of the study in the in the Mekong River, uploaded data is considered as the observed data. However, uploaded data is the outcome from the international project. This means this project will finish on the 2015. This means the uploaded data is only available up to the 2030. And my study focused on my target. The target of my study focused on the produce a more up-to-date data set than the upload data, and sufficiently really valuable for making maybe study. And the table on the slide shows some information about the two data set, precipitation data set, uploaded data, and the Percy and CDR. And both of data set have the same size, the number of row, the number of column, and the cell size about the cell size is 0.25 degrees, and the number of cells in the catchment is more than 100. You can see on this figure there is a big gap. There is a big gap between the uploaded data and the Percy and CDR. And in my study, the data set in 2014 and 2015 we use for the testing purpose. And the next is I will introduce about my methodology. So for this presentation, I will propose two methods. The first method, bias correction based on the statistical method, and the second is based on the deep learning model. For the statistical method or standard deviation, this method based on the standard deviation equation you can see on the slide. And for deep learning model, this is based on the convolutional automated neural network. And the next slide I will give us for you some detail about the statistical method and the deep learning models. For the statistical method, the data set from the 16 year are used for calculate the mean and the standard deviation of the satellite and the observed data corresponding the month. The number of cells in the catchment is more than 1,000, and each cell in the catchment have a information table like this. In this table, it shows information about the mean and the standard deviation of the satellite data and the observation data corresponding to the monthly. After have this information, I will use to correct the data set for 2014 and 2015, and the values of the grid cell is calculated based on the standard deviation equation. For the deep learning models or convolutional automated neural network, this model is a combination of the two parts, encoder and the decoder, and the deep learning model will receive the temporal input sequence is like this, and take the output is reconstruct the output. And the next slide we will discuss about the resource and the discussion. First is in terms of the temporal correlation. The comparison of total precipitation over the Mekong River by the annual precipitation and the monthly precipitation are shown in the slide, in this slide. And for the annual precipitation, the left table, we can see the corrected data by the deep learning models and the statistical method. So the good performance when the accurate rainfall over the Mekong River basin close to the observed data. And for monthly precipitation, it shows a similar trend when the MSE value in the deep learning models and the statistical model shows the good performance about 98%. And it means in terms of the temporal correlation, those methods illustrate the good performance. And this figures comparison the correlation of the monthly precipitation. You can see it so the good correlation. And the next comparison in terms of the probability distribution and the comparison of annual precipitation table itself illustrated via the Taylor diagram and the violin plot. The left is a Taylor diagram and the right is a violin plot. For the Taylor diagram, in this diagram shows the information about the three statistical indicator: standard deviation, correlation coefficient, and the IMSE, which means square deviation. And we can see deep learning model or convolutional automated neural network shows superior performance with correlation coefficient of more than 90%, and the standard deviation is about 410. Is better than statistic data or satellite data. And in the case of the violin plot, it shows a similar trend when the deep learning model shows similarity with the observed data, and the statistic data shows is not good. Some the cell receive the higher values. And the next comparison in terms of the spatial correlation and the difference in the spatial rainfall is evaluated by the IMSE, MAB, bias, and the correlation. This figure shows the spatial distribution pattern of the precipitation product in 2014. Data from left to the right, you can see is observed data, deep learning models, statistical methods, and satellite data. And compared to the observed data, the deep learning models of convolutional autoinput shows a superior performance with the correlation of 91%. And the bias is lowest, is about 40 millimeter per year. The statistic data show the poor performance. And the next is a comparison in terms of the spatial bias correlation. The spatial bias distribution is obtained by pairing pixel by pixel and then calculating the difference with each pair of these pixels. We can see in this figure is the scatter plot when compare the convert deep learning model statistical method and satellite data and with the observed data and the deep learning model of convolutional autoinput shows the best performance and it also shows the lowest bias correction among the products. And the next is some conclusion. The deep learning models illustrate the superior performance in describing the spatial latency between the addressing pixels and corrected data by the deep learning models show this to be the level of the data source in the context after this reservoir study in the lab area. The satellite-based rainfall product may be a good suggestion if the data are well calibrated, both spatially and temporally. and the proposed models could be applied to other products or higher resolution data. And here is one of the application of the convolutional neural network for the credit rainfall. This is AI contest for rainfall prediction of hydroelectric dam using the radar data. And this contest will finish on the next week. The next week 13, and my account is second place. And thank you for the time.
Okay, thank you, Dr. Hiên. I have a small question and some request. And one request, I curious to know you show the other map spatial observation to compare with other result from other model from the CNN and statistical model. Can you tell us the observation map you create based on what?
Is it a figure, right? Is it a
Yeah.
slide? So the left is the observation data. That means the output data.
Ah,
Understand?
yeah.
Yeah. And the satellite data is means Percy and CDR satellite data. And the CNN or convolutional autocoder is output from the deep learning model and statistics.
Okay. Thank you, Dr. Hiên. Do we have any question? If not, I think now is we are finished for presentation. Without one, I think the Mr. Hamid and Tesam Lee cannot join today. Maybe we can finish our session now. Do we have any comment or something to say?
No. Lee Tae Sam là professor ở trường Kyung Sang.
À, đây à?
Vâng. Chỗ cái gì ấy nhỉ? Cái trang ở trường chỉ là nó đang hôm trước em nói chuyện với anh.
À rồi cái trang này anh thấy đến này rồi. Hai bạn Tiến với hai có gì nói được không? Mình chuyển sang nói tiếng Việt rồi.
Chỉ biết thôi. Anh Tiến em cầm một cái bản đồ chỗ cái lưu vực sông Chu ấy, nó là nhỏ nhỏ thôi thì có thể anh chia sẻ cái bản đồ cái mạng núi sông ở đấy cho em được không?
Anh chia sẻ cho.
Cái đoạn em sẽ trao đổi cụ thể với anh sau nhé.
Ok.
Mr. Cheo, do you need to say something for us?
No. I just all of the question to Lee. So Hiền Lee, right?
Yeah. Dr. Hiên.
This is about the conference. Just
Yes.
have a question.
Good morning, everyone.
Hydroquay
This is I want
tutorial,
say screen.
right?
Oh, sorry, it's difficult to hear.
Yeah.
Could you speak loud?
Our take-on conference, take-on competition. You see the take-on competition.
Yes.
From the
It's
state.
my account. Yeah.
Nice to meet you. I'm Rain, KWRA.
Oh yeah.
Nice to meet you.
Can you hear me?
Yeah, thank you.
Okay, we can finish here, and maybe we can contact after the this session. Okay, goodbye everyone.
Goodbye.
Bye.
Alo, hình như là có ai